Hi folks. On this rainy afternoon, I'm playing with a friend's piano, and I thought, well, it was on my mind, so I thought I would share it. I get asked this question sometimes, and the first time I was asked this question, my philosophy 101 professor, over like a plate of cheese, bluntly was just like, why can't you tune it to the hertz? Because, it's 2023, we have plenty of instruments that register photons, even electron movements. So like measuring hertz is like easy peasy. There's even some guitar tuners that have in the corner a very kind of inaccurate number of hertz. It's like A, up here is 440. So then he said, why, I'm paraphrasing, why can't you tune the next A to 220? And then the next one, half of that. 110, why can't you just mathematically divide it up and then tune to the number, and then you're good to go. I thought a good example of this is the FA interval, an F chord, or a major, I guess. The bottom half of it is an F and an A, and then it goes up to C, or there you go, for the triad. So F and A, if I tune the F to mathematically what would light the green light up on a guitar tuner, I think that's it. Yeah. That is what would, pass off this key if you ignore the fact there's other beats in there. Whatever. If you ignore that, that would measure at the mathematical correct pitch. But you know what this sounds like? Shit is what that sounds like. So you can't leave your interval like that. And like with this F, you would pull it closer to the A, you would pull it sharp. That's almost pure. Okay, well that's almost pure. We don't leave it there. We add some wiggliness to it. But yeah, that's gonna register. Take the most general tuning app from the App Store. That'll show you hertz. You plug it in. That's not going to show you exactly an F. It'll be a little bit sharp, a few cents, like out of 100, like money. That'll register a little bit sharp, but that's what sounds good. Which on a guitar, the same thing happens. Somebody asked me once. A lot of times you have to tune the high E string a little bit flat, so that the string next to it rings nicely with it. And when the E is like up to pitch, it kind of sounds like shit. A little too brassy, it doesn't wiggle correctly, because when two wavelengths are at the point we like, they reinforce each other, they don't clash as much. So yeah, a lot of this process is quote unquote tempering the piano, pulling everything in predictable places so that it all kind of sounds good, which is not scientifically what you would graph on paper. In fact, if you do like a piano graph, it goes flatter and flatter and more sharp the two directions you go. Is it a sine wave or a cosine? I don't know. That one. Just put it in the comments.